Okay, so graphing, sine, tangent, and cotangent. Today we're just going to mostly focus on graphing sine and cosine. And we're going to get pretty intense pretty quick, though. You're going to wish that there was a stop. Can you do it? Sine. Get it? Sine. Anyway, so there is a whole lot to know about this, but would you get to this slide right here? Graphing y equals sine of x. The pretty little thing off to the left is a different kind of graph that we are not using yet, but you're going to see it before the end of the year. Does anybody know what it's called? The different kind of graph. It's not called a different kind of graph. All right. Polar. All right. So this is not a polar graph. This is kind of distracting in a way because we're not doing that kind yet. It's kind of like a foreshadowing. Yes? We'll talk more about polar when we get there. I don't want any more confusions about the polar. I actually wish it wasn't there, but I'm trying to explain why it's there and that we're not using that kind of graph yet. All right, so if you're going to graph cosine, do you get cosine versus sine? This one says sine, okay? Sine goes up first, goes up and hits 1, okay? Comes back down again, goes all the way down to -1, and then hits at 2 pi. Now, do you think it's as accurate as what I just did? Of course not. It's going to be super accurate. Okay, but this is just a rough sketch. I should probably budge this line over a little bit, though, because it should hit right at pi. All right, so there's sine. What's the difference between that and cosine? Well, cosine, I'm going to just put it on the same axis because this other one's turned all sideways, which is kind of weird. So we're going to do cosine on the same axis and just show you the difference. Cosine is starts at 1, and then it does the same exact cycle. It's just that it already is at its peak, and then it drops, and then it bottoms out halfway here at pi, and then it comes back up again and gets back up to where it was, and that's how you know that it completed a full cycle, is it's back to where it started. Okay, what is a full cycle called? It's called its period. It's what it's called. So this from here to here is 2 pi. They both completed one full cycle in 2 pi. So the period of them, standard sine and cosine period, is 2 pi. This distance that they go up and down, do you get the total swing is 2, but we would say that its amplitude was 1. So the amplitude is only from the middle up to its highest peak. From the middle line up to the highest, that's called the amplitude. So this is its amp. The amplitude is 1. So cosine and sine both have an amplitude of 1. They swing from the middle, up 1, down 1, up 1, down 1. Okay? So the amplitude's 1, and they complete themselves one full cycle in 2 pi. So their period is 2 pi. All right, so now I'm going to focus mostly on cosine today. And I want to make a new one here. You don't have to. If you can follow along on the other one if you'd like. But in a moment, I'll ask you to write some stuff down about this. All right. Without any labels, can you tell me how to reconstruct the labels? That's the number one thing you got to understand about this, is how to label your graphs. Everybody can draw a wave. It's whether you can label exactly where it is that matters. Okay? So what's this highest spot here? 1. What's the lowest spot? And then when does it end right there? 2 pi. Now, if you start there, it's all about cutting things in half. It's not that bad. Because do you get this as halfway from 0 to there? That's half of 2 pi. So therefore, it must be pi. And then, do you get that this next important spot right here is halfway between And therefore what? Pi over 2. And then this spot is the hardest one for me anyway, because the other ones you could all just cut things in half. This one you got to count up to it. This is 1 pi over 2, 2 pi over 2, and therefore 3 pi over 2. As soon as you realize that you're just going to count it up from the smallest one, which was 1 pi over 2, it's not that bad. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay, would you agree that you learned a whole bunch of parent functions back in the day, like y equals x squared, and it was like a parabola, and then you learned how to move it left, right, up, down, how to stretch it? Okay, we spend so much time on that in higher algebra that it works out pretty well, because if I go like this, you guys will probably be able to tell me all the changes I should do to my parabola. Throw a negative in there too. What's that one mean? Right, 3. What would the plus 7 at the end mean? Up 7. What would this 2 in front be? A vertical stretch. And then, yep, factor 2. And then the last thing is this little negative in front, which is a vertical reflection. Okay, it's a flip, another way to say it. Well, guess what? Sine can do the same exact thing. I can say y equals negative 2 sine of x minus. And the reason I say pi over 2 here instead of a number like 2 is that when you're moving on this graph, do you get that this distance right there is the distance of pi over 2 when you move to the right? That's why we have a little pi over 2 in there instead of a number. And then this is just a normal number again. This would be your parent sine graph, except it's been flipped upside down. So if normal sine or cosine or whatever the function you're doing starts, okay, I'm gonna do cosine, and I'm gonna change this to cosine because we are mainly focusing on cosine today. So that starts at 1, and you do need to get that difference. Kids forget. Okay, if cosine is already at its peak, is one way to think of it. Okay, it's all downhill from there. So cosine starts here and it goes all the way down, and then it comes back up again, but it's all downhill for cosine. Sine is things are looking up. See, sine's going up. All right, so anyway, if we have to do cosine, and they ask you to do this to it, you'd have to do 1, 2, 3, 4 things to the graph. 5 things? Is that what you're making? I think you're right. 1, 2, 3. Oh, looks like it's 4 things. We could actually throw in a 5th thing by throwing a number in there. But okay. So just to see if you understand what I've told you so far, I'd like you to write this one. Negative 4 cosine of x minus pi plus 8. I'd like you to just draw an arrow and tell me what you'd have to do to the cosine wave for all those things. Do it now. There's 4 things you'd have to do to your cosine wave. Vertical, reflect. If you said flip, I'll accept it, but raise your hand if you knew that one. Okay, good. Next one is the 4 is a vertical stretch. Just think for a second. If normal sine looks like this, or cosine, sorry, looks like that's a terrible cosine. I'm gonna try again. Oh, still do it bad, but anyway, if I make it twice as tall, it goes twice as much in both directions. Get the idea? That's a vertical stretch. Okay, now what's that minus pi? It's a shift to the right. Pi, how far is pi? Well, you got to have a graph up here to see. That's sine now. Sine's actually a lot easier to draw. But so this is 2 pi, right? So how far is pi? That far. So you'd grab your graph and move it over that far. That's a shift to the right of pi. Okay, and then the last one is up 8. Raise your hand if you knew those things. Okay, good. Now, we just need a more generic form of this. Y equals A cosine B x minus C plus D. And these are the letters we're going to use for this in trig, because it isn't all exactly like it was in higher algebra. It's very similar, though. Where A is the amplitude, B is, it has to do with the period, but it's the period over 2 pi. B is the period divided by 2 pi. So do you get if there was a 1 in here, then the period being B is 1. 1 is the period over 2 pi. What is the normal, what is the period then? The period must be 2 pi. For right now, just memorize that B is the period over 2 pi. I will give you an alternate form of this that a lot of kids like better. And that is because usually you have to figure out and solve for what is the period, because they're going to give you a B number. Then, would you agree if I just rearrange this equation on the same line, write this? Period will be it's supposed to be 2 pi over B. And I'm trying to figure out what I'm... Oh, I was writing it upside down. Sorry. 2 pi over the period. My bad. At least I caught you before you left. And we hadn't actually done any problems with this yet. Okay, had it upside down. Easy to do. B is 2 pi over the period. So the period is 2 pi over B. So again, if B is 1, my example happened to be, it didn't hurt me in my example, because if it's reversed, 1 equals 1 either way. But if the period's 2 pi, then you know, oh, 2 pi over 2 pi, B must be 1. Or the other way you can say it is, if you know that B is 1, I can stick a 1 in there, and you get the period is 2 pi over 1, which is 2 pi. All right. So you can use both of these equations are really handy to have, because if they give you the period, you can go, oh, they tell me the period is 2 pi, then B must be 2 pi over 2 pi. B must equal 1. Or if they give you the B is, let's say they change this to a 7, then you go, okay, then the period must be 2 pi over 7. So the last, like when it finishes, isn't 2 pi anymore, it's 2 pi over 7. All right, so that's A and B. Nope, I better redo that part. There we go. Here's C. C equals, it's called the phase shift. It's one of the differences from what you would have called it last year. When you weren't doing trig, that was called a horizontal shift. Shift to the right. Okay, but in trig, it's called a phase shift. And then there's D, which is a vertical shift, but come on, most people would just say it's up or down. The whole graph moves up or down, however much it says. Okay, next we got to pause for a second and just talk about some, like what the homework problems are going to look like and then what that means for you. If you have a homework problem that looks like this, and they ask you for what A is, it's really simple. What's A? 3/4, and that's the amplitude. It's how much it goes up from the middle and how much it goes down. This one goes up 3/4. It's the highest it ever goes, and then goes down 3/4. Okay, but then it's got this thing. The B isn't where I want it to be. I would want the B to be outside of this. Do you get we're just going to factor the 2 out? All right, let me stop for a moment and show you that. let's say you had this. That is super easy to factor, right? You just factor the 2 out, and you get 2 comes out, and then what do you have left? X minus 2. How do you know that works? Could multiply it back out. Try it. 2 times x, 2x. 2 times negative 2, negative 4. It worked. So when your problems say 2x minus pi, and you're supposed to factor a 2 out, the first part's easy. You take 2 out, and then you got x, and then here's how you do it. You think back to, how do I do this? I multiply. 2 times x makes 2x. 2 times I don't know what, but it's supposed to equal negative pi. Do you get that that's actually an equation? 2 times I don't know what is supposed to equal negative pi. Then how do you solve an equation with a variable like question mark in it? Divide by what? Divide by 2, divide by 2. Question mark is negative pi over 2. Do you get what just happened there? If nothing else, do you get that when it's done, it works? 2 times x, 2x. 2 times the negative pi over 2 makes negative 2 pi over 2, which is negative pi. It worked. All right, would you try to factor, just factor this for me. 4x minus pi over 2. Factor out the 4 so that you can find out what your C term, no, your B term is. Factor out the 4. You'll catch on to the pattern after a while. There's a little pattern that makes it super easy, but if I were you, I'd write a little equation. Anybody who can't put an X there, it scares me. But this next part, I get. This can be tricky. Who can tell me the little equation I should write? Yes, sir? Yep. I don't want it. The reason I don't want to use X is because we already have an X in the problem, and so you could use like Q, or you can do whatever you want, but I'm going to use a question mark. You can, yeah. This times I don't know what's got to equal that. Perfect. So then you solve for question mark. So how do you do that? You could divide by 4, or you could multiply by 1/4. And that makes it negative pi over 8. Raise your hand if you had negative pi over 8. Awesome. That is the hardest part, honestly. Because when you remultiply this out, 4 times x makes 4x. 4 times negative pi over 8 makes negative 4/8 pi, which is the same as negative 1/2 pi. Yay, it worked. Why is that so important? Because now, when you see a problem like this, you won't have any trouble finding out what your C term is and what your phase shift is, because let me give you a hint. Your phase shift is not negative pi over 2. You won't know your phase shift until you factored the 2 out. You got to get that 2 out in front of the parentheses. Otherwise, you don't have the phase shift in there. Okay, so everybody take this equation, factor the 2 out, and then tell me what's A and what is it. Like A is this much, and it's, what is it? It's the Wagenschnudel or whatever this is. Okay, B is what? And give me the 2 equations that equal B. C, you'll figure out C. C isn't too hard. What's C? Just tell me what C is. C is 2, because you're going to take the 2 out, right? So you'll have a 2 right there in a minute. But that is the B term. Sorry. C is the part that'll be left over in here, and it's not pi over 2. C will be different once you factored out the 2. And then what's it called? And it's got 2 words. P and S are the 2 initials. And then the last thing is, what's your D? And that's super easy. Okay, try to solve that one. That is a typical homework problem for today. And the only other thing left in the next 15 minutes is I got to just show you how to make sketches of them. Yes, sir. They are capitals on your worksheet today. and it doesn't really matter. But thanks for asking. I know you're going to kind of get used to something. You may as well get used to capitals. You seem confident. Miss R, tell me the first few. You are correct. And what's it? Definitely not the Wagenschnudel. What is it? 3/4 is the what? It's called the M. There you go. And yes, you're right. It's something else. Back in the old days, we called it the horizontal stretch, but now it's, no, vertical. Sorry, vertical stretch, but now it's called the amplitude. All right. Want to go a little further? Can you do B? Good, because once we factor the 2 out of this, did you actually get the factoring done? Okay. When you factored it, did you have 2 and then x, and then what did you have? Yep. How do you know you're right? You can just multiply it back. 2 times x makes 2x. 2 times negative pi over 4 makes negative 2 pi over 4, which is negative 1/2 pi, which is what we had. Okay, good. Cool. You've done it right. So B's the what? Well, I asked you to write 2 equations for that. Do you remember either? B is, and I messed this up last time. Who can do it better than me? Yes? No, B, it can't be 2 pi over B. That's the other one, though. Period is 2 pi over B. That's one of my equations. But B, then, if you've got that one right, you can just rearrange it. 2 pi over the period. Is that what you said? Sorry. That's the hardest one for me, because I'll be honest, the reason that one's messing me up so much is we never did that in regular. In regular, it was this one. So this one's burned into my brain. 2 pi over B, 2 pi over B. So then to rearrange it, it's like, it's not that hard. If you start with that equation, then you can just move this and this. But if you try to start with B, my brain wants to say 2 pi over B. Anyway. Okay, so there's my 2 equations for the period. In this case, I know the B. Do you get that means I can go stick it here and say the period for this function used to be 2 pi, but this changes it. It used to be 2 pi, but now it's 2 pi over 2. What is the period for this new function? Just pi. Normally, cosine has period of 2 pi. But this changes it. The B changes it. If there's any number right there, then you've changed the period. It doesn't finish at 2 pi anymore. It finishes at, in this case, pi over 2. 2 pi over 2, sorry, which is pi. Okay, and the next one is the C term, and the C term is this guy. After we factored it out, I'll circle it with something different. I'll box it with this. That is your C term, negative pi over 4. And that means it's a phase shift, and phase shifts always have to have a direction. If you had just phase shift, I'd have to mark off some small percentage because you didn't say which way. So what's this one? Phase shift right. Why is it right? Because it's got a minus in there. And the last thing is D, which is the super simple one. It's that, and that means up 7. If you wanted to describe it as a vertical shift, that would be fine. All right. How many of you had those right? Okay, only a few, so I'm going to do one more like that. Y equals 2/3 cosine of 4x minus pi plus 2. You should be able to tell me. You don't have to label them all. Just tell me what's A, what's B, what's C, and what's D. I know A is the amplitude. Okay, A is 2/3. B is 4, because you're going to factor the 4 out. C might take you a little longer because you have to actually factor the 4 out. And D is going to be 2. Those are the no-brainers. Okay. What'd you get for your C term after you factored out the 4? What did you have? 2 people answering. Whoever feels motivated. Okay, then one of you, quickly. Okay, so I have to have something first here, though. Okay, minus pi over 4. And if I wanted to be sure you were right, I go like this. That times that, 4x, that times that, negative pi. Yes, you did it right. And therefore, you figured out the C term, which is negative pi over 4. If I want to change that to degrees, you remember even what that is anymore in degrees? Remember it? Pi, half of that. 45, there you go. 45 degrees. But in the context of one of these graphs, it's going to move how many marks? Well, it depends on what you've labeled the marks as. All right. So now we have to get into the sketch part. And again, I know your brain is almost like full here, but this first day, it's going to be a little bit challenging. But by the time we're ready to take the test, you'll be fine. All right. I want to actually do one of the problems of your homework. Like, let's do one of your homework problems together. Okay? So find where it says day 1 problems. It's quite a few pages down because this is a 3-day lesson. So it's like page 30 something, I think. I don't know. Pause for a second while you find it. Okay, so here it is. Students are telling me it's like page 33 or 34, something like that. So A, B, C, and D are going to be easy. We just practiced that part. Let's actually do that, but then let's actually make the sketch of this thing. Okay, so A is what? 3. Well, it's B. 1. What's C? Did you shift it 1? Is there a minus a 1 in there or a plus 1 in there? No, it didn't shift it at all. 0 shift. And then how about the D? 0 shift. And then so there's none. None. And it's asking me for the period now. Do you have a formula for that? Period is 2 pi over B. Memorize that. 2 pi over B, except we know what B is. In this case, B is 1. So it's 2 pi over 1, which means the period is 2 pi. Do you get it would kind of default to a period of 2 pi? That's kind of normal. And if the B term, which is the number that's right in there, if the B term is there a number there? Like if there's a 3 there, then you're changing the period. It's kind of like a horizontal stretch or shrink. All right, and the last thing is the amplitude was 3, and we already had that. There we go. Okay. I hope you feel like that first part's easy. Okay, now this next part, I want you to draw a standard sine graph. Oh, no, wait, is this sine? Yeah, it is sine. Sine graph. So, and you get to pick on this, but for me personally, I'm going to lean towards making 2 marks be my high spot and 2 marks being my low spot. And so that means I'm going to label these with a 1 and a negative 1. That's for standard. You're graphing the parent one first. Then we'll go back and make the changes. This one's only got 1 change. It's got an amplitude of 3 instead of 1, but we'll deal with that later. Okay, next, actually graph sine. But you really need to know where it's going to end so you can know how to like act in the middle. So this is 1/4 of the way there. Every couple marks. So you have 4 main spots. Do you remember where the end was? Nope, not pi. 2 pi. Because these things finish up over the course of 2 pi. That's like going all the way around the circle once, right? Okay. So now let's draw a normal sine in here. Starts at 0 and sine's got nowhere to go but up. And then it comes back down again. Goes all the way down to its lowest point. Goes back up again to right where it started, and then you know you're done. That's a complete cycle. That's normal sine. Now, You have the right to use any labeling you want, but you have to label it. If you just don't label it, I get to mark it wrong. Okay, but if you've labeled it, I could decide all of a sudden that's for this problem, I want this to be a 3 amplitude. What little forgery could I do that would make my life really simple? Change the 1s to 3s. You get what I mean? Because I got to decide what I want that to be, so I'm going to say I want it to be a 3. Now I'm saying my graph goes up to 3 and is down as low as -3. Probably throw a negative on this one. You see what I mean? Now, you could have actually stretched this thing and gone 3 times as high, but to think about it, it wouldn't even fit on the graph anyway. You know what I mean? So there's downsides to that too. If I wanted to make this thing go 3 times as high, 3 times as low, I'm going to be guessing at the ends where it should be. So it may as well just change your labels. Make sense? Okay. Now let's do number 2. And by the way, your assignment is to do the first 9 questions. There's 9 in a row. You can do all of them. Some of the ones at the end, I will warn you, get to be a little dicey on the graph part. You should be able to easily do the ABCD thing, but actually making the picture right will be a little tough on the last couple, and that's okay. Just fight your way through it. Give it your best shot. And I'm giving you more time than any other class to actually work on this. Because we're in your homework and we still have like 15 minutes left. Okay? So let's try this next one. And this one's going to have that B that's going to make things change as far as the, it's not going to finish at 2 pi. All right. So on number 2, what's the A? 1. What's the B? 3. You can factor it out so easy, right? You just drag it out to the front, and now it's y equals, you could say 1 sine, and then I put a 3 here, and then I say x. I mean, that's factored, so good enough. B is 3. What's C? Didn't shift at all. And what's D? Doesn't shift up or down at all. So you could say plus 0 in there. You do not have to do this. I'm just trying to show you. Some people don't get why this is 0. It's like there's a 0 here and a 0 there. Okay. Then the amplitude's 1. The period is not just 3. That would be wrong. There's a formula for that. Period is 2 pi over b. Except we know b. What's b? 3. So our period is 2 pi over 3. Now horizontal shift, none, and none. So how do we do this? First, you graph the parent one. Don't try to jump right to graphing it with this new weird period. Don't do that. But I'm going to graph the normal sine, and just like I did last time. In fact, I'm going to cheat, and you guys can too. Clone, bring her down. You don't have a clone option, but you have like a scissors on yours, don't you? Okay. There. Now I should label it. Yes, you need to label it. So strategically, since I don't have any stretch, I may as well just label it right with a 1 and a -1 right away. Know what I mean? And I can tell I didn't shift mine down quite far enough. There we go. And this then should be a 1 for that second mark. And a -1 is on that mark right there. Okay. And now this should be 2 pi. There, I've made the parent one. But, and it's a big but, that would be if it had a period of 2 pi. What does this one have a period of? 2 pi over 3. So, do you remember me saying before that I get to label these anything I want to? So, why don't we relabel it and say instead of that being 2 pi, now it's going to be 2 pi over 3. The only catch is, this is cruel, you have to label one more spot other than 0. So if that's 2 pi over 3, I'll give you a hint. What did this one used to be? That used to be pi. What did I do to the original 2 pi? I put it over 3. So take a wild guess. Well, I'm going to do that one. Put it over 3. That's 1 pi over 3 as opposed to the other one, which is 2 pi over 3. You need 2 things labeled on your x-axis. Otherwise, it's too easy. You can just change your period to 1, whatever the new period is, you just change 2 pi to that and you'd be done. It's not going to be quite that easy. Okay, so again, if you just take your original numbers and you say this was a 2 pi, I just have to divide everything by 3 because that's what the new periods did. Compared to the old period, it's just divided by 3. All right, on to this next one. Do you get, it has 2 things that have been done to it. One thing I won't let you do is forge that, you know how this used to be going up 1? Is right at that spot right there, and this used to be going down to -1. And I said you could just forge this to a 2 and a -2. That negative in front, you can't fake that by changing it to like a -2 up here and a +2 down here. No. You're going to have to actually redraw the graph to do that. So let's get the parent one on here. Once again, a little forgery. Copy. All right, I'm just actually do clone. And bring it down here. There we go. That's my parent one. Oh, is this? Ooh, this is cosine. Ooh, no forgery allowed. Dang. Okay, cosine. Sorry. Cosine, I should still make these 4 little marks are my key marks. Cosine starts by going down, bottoms out, comes back up again. There's my cosine. Except I should do my ABCD things here. A, ooh, this will catch some of you. What do you think A is? 2. Do you get what just happened there? Can you have a distance that it's going up and down be a negative distance? No. So even though there's a -2 in front, you just say 2. Technically, it's the absolute value of whatever A is. That's your amplitude. Okay, your B term, 1. Your C term, 0. D term, good. So there's no shifts because there was nothing in here and nothing out there. The period, well, it's 2 pi over B, and B is 1, so it's just 2 pi. Cool. So I can relabel this with a 2 pi. All right. And you'd be tragically wrong. What's the one thing I haven't done yet? Flip. This negative in front is saying to do a vertical flip. So I'm going to redraw it in green here. And this just takes a little bit of artistry. There. Get rid of the blue one. Get rid of the rest of the parts of the blue one here. Oh. What? Okay. Not good. Total destruction of my... Where was I? There we go. Good. Okay. I'm just going to leave that little blue piece in there because it wants to stay there, so I'm not going to mess with it. Okay. So anyway, here's my graph. They're going to get a little more complicated on the graphs at the end. And that's all I have for you for today.